So when it gives you this value of 30 cubic feet per minute, shouldn't you be able to write down what that is using D's?
Yes.
30 cubic feet is gonna discuss what concept? Volume. So that means this is dV, and minutes would be dt. So I know the rate at which the volume is changing, even though it didn't use the word volume. So it says, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. So you've got a cone, and it's telling you the diameter is always equal to the height. Okay? How fast is the height of the pile increasing? So what is it asking you to find?
The rate of
Find dH dt. Could you go ahead and write down the units for that? What units would the height be measured in? Feet per minute. And it's asking you to calculate that at the very moment that the pile is 10 feet high. So that's when the height is 10 feet. So we'll use that to substitute in a minute.
So you can use the volume for a cone?
So I need to use the volume for a cone formula. So volume for a cone is
1/3.
1/3
R squared times height.
R squared times the height. Very nice. Yes?
And can't you take the diameter and do 2r equals h?
Yes, absolutely. That's exactly where we need to go. 2r is going to be h. So what is r the same thing as? H over 2. Did they give me any information about dr, dt, or any of the rate? No. So we don't have any information about the radius, so we want to remove that and do it all in terms of height and volume. So right here in the place of r, hopefully you've completed this substitution, yes?
Yes.
Yes.
So that's going to give me 2 squared is 4 to 1/12 pi. H cubed is really our volume formula. So what do I do now?
Take the derivative.
Take the derivative, right. We want the differential equation since all of our information is describing rates. So dV dt would be
1/4
1/4
pi h squared
pi h squared
dH dt.
dH dt. Now substitute in the values that you know and solve for dH dt. Okay, so we have 30 equals 1/4 pi times 10 squared. Hopefully you're able to get 30 divided by 25 pi. Can you give me a decimal value for that? Because that really does not tell me.
Like 1.2.
I didn't get
No.
1.2. This is going to be like 30 divided by 75 something.
It's
Oh, you mean with the pi in it
With the
too.
pi and the denominator, yeah. I want a real decimal value so I can really figure out how quickly that height is
3.77.
increasing. Huh?
3.77.
3.77?
Point.
I got 0.377
Oh, yeah.
38.
pi.
Okay, yeah, point.
Make sure your pi is in the denominator.
0.382.
Yes.
What?
0.382.
Why does it go from 1/3 to 1/12?
Right, y'all? 25 times 3.14 is like 75 something. 30 over 75 would be a decimal of point. Got it. Put it in parentheses, make sure your pi's there. So this answer would be
Could you still do it?
0.38 feet per minute. So that's the height at which that pile is increasing. Each minute, the pile is getting 0.38 feet higher.
But because you can't take the derivative of this clean.
Good?
So if you added all your things together,
Yeah?
then you can.
So that's the thing.
Okay. So next we had to go with page 146. Could somebody get that worksheet out and read the first question to us? Which was what? What number was the first one? Huh?
21.
21? Does anybody have that page 146 nearby? Good, would you read it, Aaron?
Yeah. Alright, at a sand and gravel plant, sand is falling off of a conveyor belt and onto a conical pile at a rate of 10 cubic feet per minute. cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet high?
Would you say the diameter is 3 times the altitude?
Yes.
Okay? So the diameter is 3 times the altitude. Isn't the altitude the same thing as the height?
Mm-hmm.
Could you give me the other piece of information that it gave you, Aaron? Find what? The rate at which the height is changing?
Yeah, when the height is 15.
Find dH/dt when the height is 15. So isn't this the same concept we just had in that last problem? The only difference is now the diameter is 3 times the altitude. So here's our cone. I'm gonna rewrite the diameter as 2r equals 3h. So doesn't that mean the radius is always 3/2 of the height? So again, you're gonna go with your volume formula, 1/3 pi r squared h. Change your r's over to the h's. Do you get 3/4 pi? Can anybody verify that?
Yes.
Yes, can I get one more person to verify that?
Yes.
Did you really think about it before you just said yes? Even that doesn't help me. Thank you, all right? Square that. 9/4 times 1/3
Okay.
would be 3/4 pi. Thank you. So now we'll take the derivative, dv dt. Does our derivative give us 9/4 pi h squared dh dt? And now input the values that you know. Your height is 15, your dv dt was 10. I think I get 2025 pi over 4. Right? 15
Yeah.
squared
Oh, yeah.
times 9. Now you're gonna multiply by 4 and divide by, so do you end up with 40 over 25 pi?
Yeah.
Yeah, okay. So when I do that calculation, I get 0.006 feet per second is what dH/dt equals. Can anybody verify that? That's the right answer?
Yes.
Okay, great. What is our next problem? 24. Anybody need a minute more on 21? Okay, can somebody read number 24 out loud slowly enough for me to get all the information? Okay,
Alright, a trough is 12 feet long and 3 feet across the top. You wanna
Okay.
keep going? I thought you were
is
gonna
there
go.
a picture?
Oh,
it's
yeah.
weird.
It's like a upside down rectangular prism.
Can I see it?
It's an upside down tent.
Why does it say rectangle triangle?
It's in the same.
Screw it.
Y'all got me messed up, okay?
It's like a rectangle pyramid.
I know, but.
It's a rectangle. I was thinking about the rectangles.
Yeah,
Okay.
Okay,
Yeah.
I guess it's on the pyramid.
Okay.
It's an
Keep
upside
going.
down tent.
yeah.
Alright.
What shape is this?
It's a trough, it's a triangular prism.
So trough is 12 feet long and 3 feet across the top. Its ends are isosceles triangles with altitudes of 3 feet. If water is being pumped into the trough at 2 cubic feet per minute, how fast is the water level rising when the water is 1 foot deep?
What would the volume formula for this be?
Okay, we're gonna get there. I need to write down the other information. The volume's changing at 2 cubic feet per minute, correct? Okay. Tell me the other thing.
When the, it says how fast is the water level rising?
Okay.
When it's,
So what geometrical concept is the water level going to
Height.
relate to the height? So how fast is the height changing? That's what we're trying to find. That would be in feet per minute when the
When it's 1 foot deep.
when the height is 1 foot. So we'll use that 1 foot height, in a little bit to substitute. As you're putting water in this trough, is the height, the water level, the height of it, changing at the same rate the whole time you're putting water in? No. Isn't the rate at which the height is changing gonna be faster down here at the bottom because there's less volume to be filling up? So it looks like the height would start out changing pretty quickly, but then as your trough gets wider, doesn't that make the height change differently? So DHDT is not gonna be a constant value. It changes. At 1 foot, it'll be some rate, and then at another height, it would be a different rate. How do you find the the volume of this prism? Area of the base times the height. How do you find the area of this base? 1/2
3.
base times height. Now, is it always going to be 3 and 3 for the water level? No. The tank is 3 and 3 and 12. And then times, now will that 12 be changing? That 12 is definitely going to be the same because the trough is 12 feet long regardless of how much water is in it. But this 3 and this 3 is not going to be consistent with the water level, correct? So do you notice here that the height is equal to the base? Remember how we discussed those similar triangles yesterday? No matter how high the water is, won't the altitude and the base of the triangle be the same? If there's 1 inch in it, then the height of that little triangle would be 1 inch, and the base of that triangle would also be 1 inch. So this is telling me that the height and the base are going to be the same. So really our volume would be 6 times base times height. Do I want to do this in terms of the base dimension or the height dimension? The height, because it asked me how quickly is the height changing. So I'm going to change this over to my volume formula would be 6 height squared. Okay, so now you'll take your derivative. dV dt is 12h dH dt. And then you can plug in the values that you know. Two equals 12 times 1 dH dt. So 1/6 would be the rate at which the height is increasing when the height is just 1 foot. What would those units be? Feet per
minute.
I think this one was in minutes.
Yeah, it was.
Was this minutes? Yeah, feet per minute. So that height would be 1/6 feet per minute. Okay, can somebody help?